In this video, we're going to take a look at trying to accelerate convergence of sequences. So we're going to start with taking a look at a sequence. So let's say we have some sequence, so p sub n, and that sequence is linearly convergent, right? So the rate at which it converges is a linear rate of convergent, and it converges to a limit of p. We're going to try to create a second sequence built upon this first sequence. And this second sequence, we want it to converge more rapidly to this value p. Right? And so we will make some assumptions. We will slowly build out this process. But the first assumption that we have is assume that the differences in that first sequence between the nth term and the value it's converging to, the n plus 1 or n minus 1 term, the n minus 2 term, assume that those are all have the same sign. The same sign. And those should be pluses as subscripts. So p sub n plus 1, p sub n plus 2. If we assume all these things have the same sign, we are then also going to assume that our value of n is large enough so that the difference between the n plus 1 term and p, that ratio compared to the difference between the nth term and p, is approximately the same as the difference between the n plus 2 term and p, the ratio of that to the n plus 1 term and p. All right, so the ratio of the differences are approximately the same as you move from one value to the next. If we make those assumptions, then we can start doing some algebra with this, right? So we can multiply both sides by the denominators. If we multiply both sides by the denominators, we will have p sub n plus 1 minus p squared is approximately equal to p sub n plus 2 minus p times p sub n minus p. And continuing to roll through some algebra, we get p sub n plus 1 squared minus 2 p sub n plus 1 times p plus p squared is approximately p sub n plus 2 times p sub n minus p sub n plus 2 times p minus p sub n times p plus p squared. We could subtract p squared from both sides, and if we do that, we have, and we can move some other things around. Move anything that has the value of p over to one side, and everything else to the other side. And if we do that, we have p sub n plus 2 times p minus 2p sub n plus 1 times p. The p squareds will cancel out. Then we'll have plus a p sub n times p. That should be approximately equal to p sub n plus 2 times p sub n minus p sub n plus 1 squared. And if we keep working through this and solve this for p, right, so you can factor a p out on the left-hand side and then divide both sides we get this value of p is approximately p sub n plus 2 times p sub n minus p sub n plus 1 all over n plus 1 squared all over p sub n plus 2 minus 2 p sub n plus 1 plus p sub n. So we have that's an approximate value for p. All right, so this is describing how we can combine some terms together to get an approximate output for the value of p. Now we could do a little bit more algebraic manipulation. All right, so we can add and subtract the same value to both sides, and that shouldn't change it. Add and subtract the same value from a single side, and you could do it to both sides, but to one side, and then you can manipulate some things. So in particular, we can add a p sub n squared to both sides. We could also add p sub n squared and subtract p sub n squared from the right-hand side, and do the same thing on the right-hand side with 2p sub n times p sub n plus 1. And if we do that, then what we should end up with is this value of p is approximately, I'll go ahead and group and do some factoring stuff. That value of p is approximately p sub n minus p sub n plus 1 minus p sub n all squared divided by p sub n plus 2 minus p sub n plus 1 plus p sub n. Yeah, so that gives us a way that we can find a new guess. We're going to find our new guess by combining things appropriately, right? Yeah. So this method, this process, it is called Aitkens Method, Aitkens delta squared method. And the terms of this p hat sequence, these terms are going to be equal to the nth term of the initial sequence minus the n plus 1 term of the initial sequence minus the nth term squared divided by the n plus 2 term minus 2 times the n plus 1 term plus the nth term. Right? So here, this gives us a way to build up a new sequence based on some other sequence. Now this sequence, the way that we determine this value is we look at so the first value here looks at the first 3 values of the other sequence. The second value looks at, of this p hat sequence, we'll look at the second, third, and fourth value of the other sequence. So there's a little bit of a startup cost, but then to continue on, you're just going one step further, and there's not an additional cost there. All right. In our next video, we'll take a look at an example where we apply Aitkens Method. I will see you there.